Right. So I'll be talking about mind games, targeting theory of mind in large language models with dynamic epistemic modal logic. So this paper is found got accepted in the findings of EMNLP. So I want to talk about my notes here. So we will be um, yeah, explaining it. So to summarize what's going on here, um, people claimed like big LLMs had theory of mind, which is like the formal definition, ascribing mental states to others and understanding their mental states can be different from your own. And the reason is because like they passed like classic mind reading tests. So this paper says those tests may have leaked into the training data and they're too simple. So the authors built a machine that generates fresh controlled mind reading puzzles from logic puzzles. Like no model could have memorized and tested whether models can actually do the reasoning. Mostly they can't. So the Muddy Children puzzle consists of like two kids, Alice and Bob, each have mud on their forehead. Each can see the other's forehead, but not their own. So you have Bob here, and then you have Bob can see the mud on Alice, and then Alice can see the mud on Bob. And their dad says, at least one of you is muddy. Then he asks, do you know whether you are muddy? So round one, both say no. Well, technically, like I don't know. And then for round two, after the dad asks these series of questions, both say yes. So what's going on here in terms of like the picture is like if Alice were clean, then have to be the muddy one. Um, so he says, I don't know, right? And Alice thinks Bob doesn't see a clean face on me or he'd know he's muddy. His I don't know means I must be muddy too, right? So this the same logic runs for Bob. So that's why because Alice thinks this way and also Bob thinks this way, both of them answer yes. The punchline here is like Bob's I don't know is itself a clue. Like even an announcement of ignorance changes what everyone else can figure out. That's like the whole idea with the paper test, like reasoning about knowledge, including knowledge about other people's knowledge, and how public statements update it. This is like the definition of dynamic epistemic logic. And then what the authors actually built is like they made a generator that stamps out puzzles like the Muddy Children automatically. And the way they do that is like you have agents, like the people, which consists of random names, the predicates, which consist of like true and false statements. They call it observabilities, but like the more like colloquial term would be like who can see what. And the setup, it decides this. You can see others' forehead, but not your own. And announcements, like public statements made in order that update everyone's knowledge. And hypothesis, and the formal definition is here. Yeah, an expression that may contain predicates and knowledge of agents about particular expressions after the announcements, given the agent's observabilities and announcements are grouped into a premise. So they ask a trick question like, can Robert now know whether everyone is muddy? And the logic engine computes the guaranteed correct yes or no answer, basically like phrasing the whole thing into a true and false label. And like the question is like why this matters. It's because like a logic engine writes both the puzzle and the correct answer. They can make unlimited fresh puzzles, crank up the difficulty, and be certain nothing leaked from the internet. So the nice sanity check they have is like they trained a small model to sniff out puzzles that could be answered by cheap surface tricks. So they could throw these out and keep only puzzles that need real reasoning. So what they found in actually section four is like humans, they basically do 94% correct. It's hard but doable. The Pythia language model that they use, like scale them up, but did not reliably help. Scaling them up did not reliably help. So the big claim they have here is earlier excitement that theory of mind emerged as models got bigger, which is claimed by Kozinski, probably wasn't real reasoning. It was likely memorized tests for shortcuts. Because like on fresh puzzles, the supposed ability mostly vanishes. So GPT-4 was the best um, like the answer from GPT-4 answers look like careful reasoning, but sometimes are just wrong. And GPT-3 T3 kept dodging. There's like it basically claimed like there's not enough info. The one-line takeaway is when a model cannot memorize the test, its mind reading looks a lot weaker than the headline suggested. So like looking like reasoning is actually very different from actual reasoning. That's one of like the key takeaway. And one of the ways they talk about the kth order belief, which is in the very bottom, is like first order belief is a claim about one person knows about a plain fact. That's order one. And then for the kth order belief, it's just the same structure stacked k times, k levels deep. So to put it more precisely, kth order belief is a first order belief about uh K minus one order belief, right? So like Alice knows whether Bob is muddy, Alice knows whether Bob knows whether he's muddy, and Alice knows whether Bob knows whether Carol knows, and so on. So this is like order three. It really reminds me of what like I don't know if you remember if you guys watched the series of Friends where like um Phoebe, Monica, um Monica and Chandler are dating, and then Monica and Chandler are dating, and Rachel and Phoebe, yeah, they play this game where like they know they're dating, but they know that they're dating, but do they know that they know that they know that they're dating? So this it can go on and on and on. So like Monica, I think Rachel asks like Joey, um, like do they know that they know? Do they know that they know that we know? Or something along those lines. Yeah. Let me see if I can actually find the exact phrasing. So the say like they definitely don't know that we know that they know. So it can be like stacked like that. So just seeing like that is kind of interesting. Um, so here they have the observabilities, which is a essentially a series of ma it's a matrix um of size n by n, where OIJ means that the agent I initially knows whether predicate J is true, and they're able to generate a series of like logic games, that can get really complicated later on. Um, and then they feed this into like, GPT-4, GPT 3.5. And then one of the questions we got in the reading group was like, um, if like these fancy models like Opus 4.8, GPT 5.5, if they're able to answer and do really well on theory of mind tests, does that mean that LLMs have theory of mind? Um, I think I want to answer with like what the Omen argued in his paper, which is like it's not really enough to that they were actually like past these theory of mind tasks. What's really important is like they're actually able to reason about these tasks. Also, even if like the theory of mind tasks can get actually really complicated. So that's like a really interesting point. That's kind of all I had for today. Thank you so much for watching. I will see you next time. Thank you.